Let's look at the first case study, an agile exploration of clinical medical records. A clinician is generally not an expert in using SQL. So to help them, I've designed a easy-to-use specification language. In this example, a clinician will enter two concepts. First, proteinuria. Second, heart disease, heart failure. The concept of proteinuria is defined by 5 positive concepts and 1 negative concept, as you can see here. So a negative here is if the code is present, then the patient doesn't have proteinuria. Now, whereas if the other codes are present, then they have proteinuria. Because a clinical code is a time series, we have to define the time frame. In this case, we want the data from 1900 to 2005. We also want, in the series, we also want the earliest observation, E1, the latest observation, L1. Apart from that, we also want the system to return a code and a date that is associated with the code. So in this particular query, we'll return 4 variables, which is a combination of earliest one, latest one, code, and date for any of the given codes there. But this is only associated with proteinuria. Let's look at the heart failure. Everything is just like as before. However, this time we ask for the earliest one, code, and date. So in this case, the heart failure will have 3 associated variables. We also have G58 percentage here. The percentage is a wildcard, so any codes that have G58, such as G58.1, G58.2, and so on, will be considered as heart failure. Just so that you understand what these codes mean, the second step of my system would actually go to the code data dictionary and retrieve their definitions. So now every code has an associated definition, and we see that negative R1100 is albuminuria. So that's not proteinuria. So this is why it's excluded from the code. And you can see the rest of the baseline system in heart failure and so on and so forth. So typically this information you get from a data dictionary. Let's consider a conventional workflow and compare it with an agile workflow to see how the latter can speed up the process. On the left, the clinicians will specify the concept of interest. The data are then extracted, columns are then merged. After that, columns are further selected. And this process takes around 8 to 12 hours. Having done so, the metrics are then formed and data are modeled and then visualized. We see that the data extraction process can be very time consuming. Hence, in the agile workflow, we move the data extraction as a separate process. Rather than producing columns, we produce a sparse temporal matrix, and this only needs to be computed once. The clinicians then can engage in a rapid cycle of data extraction and modeling in an efficient way. Now, in our experiments, we could do this under 12 to 14 minutes to process about 1 million patient records. Therefore, an agile workflow can significantly increase a clinician's work productivity. Let's compare a conventional workflow with an agile workflow. From a clinician's perspective, the conventional workflow will require some SQL knowledge, whereas the agile workflow does not require any SQL knowledge. The processing time in the conventional workflow can be slow if it's not implemented correctly. Plenty of optimization tricks are required to make the SQL works. An agile workflow has no SQL elements, and it takes faster to process, and we estimate there's a 24-hour speed up depending on the data set used. In the conventional workflow, constraints are specified by using SQL, whereas using our agile workflow, we use a formal specification language. Effectively, the use of a specification language avoids the need to formulate constraints in SQL. As a result, we see that the agile workflow is much more efficient and it doesn't require an SQL expert. Therefore, we should really help clinicians by giving them a tool to identify clinical codes faster. So I use the QICKD, which is the Quality Improvement Chronic Kidney Disease dataset, which has 1 million patient records to benchmark the two workflows. The data extraction time would include loading, processing data dictionary and database, and writing to the big CSV file. We did two data extraction case studies. The first one is disease prevalence with dates, and the second one we extract key variables into a big table. The dense matrix that we produce in the first case has 124 variables, and it took about 19 minutes on a virtual machine desktop. The bigger data set, which has 668 variables, took about 40 minutes on a server. And I observed two things. First, the time used to identify the clinical codes is actually longer than the time to process the codes. And second, this is an iterative process.